Hey there, and welcome. Today we're going to break down step by step how to calculate a super useful tool in statistics, Spearman's rank order correlation. You'll also hear it called Spearman's row. So here's what we've got on tap. First, we'll talk about why you'd even need a tool like this. Then we'll roll up our sleeves and walk through the whole calculation. And finally, we'll figure out what that number we get at the end actually tells us. Okay, so first things first, why can't we just use a standard correlation for everything, right? Well, let's get into the specific situations where a tool like Spearman's row is not just useful, it's absolutely essential. And this really gets to the heart of the matter. How do you measure the relationship between things you can rank, but can't really, measure precisely? Think about it. You know who came in first, second, and third, but you have no idea what their exact race times were. Or maybe you know someone strongly agrees with a survey question, but how do you put a number on that feeling? It's tricky. Well, this kind of info has a name. It's called ordinal data. It's all about the order, the rank, not the exact nitty-gritty values. Like in a race, the gap between first and second place might be a fraction of a second, but the gap between second and third could be like 5 seconds. Standard correlation methods, they get totally thrown off by those uneven gaps because they need precise numbers to work. And that, right there, is the exact problem Spearman's row was built to solve. It's smart. It just ignores all those messy, uneven values and focuses on one thing, the relationship between the ranks. All right, you ready to dive in? The absolute best way to tackle this calculation is to set up a nice, organized table. Trust me, this is going to be our foundation for the whole thing. So we'll start with our data. As you can see, we've got 10 students here. For each student, we have 2 pieces of information. Their rank in an exam, which we'll call variable X, and their rank in a totally separate test, which is variable Y. Our mission, if you will, is to figure out if doing well on the exam is connected to doing well on the test. Okay, now for the first really crucial step in our calculation. This is where we start to see how the ranks for each student actually stack up against each other. So what we're going to do is add a new column to our table. We'll call it D for difference. And it's super simple. For every single student, we're just going to subtract their rank in test Y from their rank in exam X. And voila! Here's what that looks like. Take student A, for example. Their exam rank was 1, we subtract their test rank of 4, and we get -3. Easy. Or look at student C. It's just 3 minus 2, which is 1. Oh, and check out student I. They had the same rank on both, so their difference is, you guessed it, 0. We just keep doing that simple subtraction all the way down the list. Now, the next step is pretty clever, and it's important to know why we do it. See, right now, we've got a mix of positive and negative differences, and if we just added them up, they might cancel each other out, which we don't want. So, by squaring each of those D values, 2 things happen. First, all the numbers become positive, and second, it gives a little more weight to the bigger differences, which is perfect for what we're trying to do. And here's our final column all filled out. For student A, that -3 we calculated, well, -3 squared becomes a +9. For student J, their difference was 2, so that becomes 4. We just do that for every row, and now our table is complete. Our data is prepped and ready to go. After all that work setting up the table, it all comes down to just one number. All we need to do is add up every single value in that last column, the D squared column. In stats, we use the Greek letter sigma to mean sum, so we call this final number sigma D squared. So when we add them all up, that 9 plus 1 plus 1 and all the rest, we get a grand total of 20. Remember that number, 20. That is the key value we need for our formula. All right, the heavy lifting is done. We've got our sigma D squared, which is 20, and we know our sample size, N, is 10 because we have 10 students. Now it's time to plug everything into the formula. Okay, here it is, the Spearman's row formula. I know it might look a little intense at first glance, but don't worry, we literally have every piece we need. That RS is just the symbol for row. We already figured out that sigma D squared is 20. And N, that's just how many pairs of data we have, which for us is 10 students. Let's just walk through this one step at a time, nice and easy. So we start by plugging in our numbers. The formula is 1 minus that whole fraction. The top of the fraction is 6 times our sigma D squared, so that's 6 times 20. The bottom is N times N squared minus 1, so that's 10 times 10 squared minus 1. Okay, let's simplify. On top, 6 times 20 is 120. Easy. On the bottom, 10 squared is 100, minus 1 is 99, and 10 times 99 is 990. So now our whole problem is just 1 minus 120 divided by 99. If you pop that in a calculator, 120 divided by 990 is about 0.1818. And for the final step, 1 minus 0.1818 gives us our result, 0.818. Fantastic. We've got our number. But hey, a number by itself is pretty meaningless, right? So what does this 0.818 actually tell us about the connection between the exam ranks and the test ranks?
Believe it or not, this one little number summarizes the entire relationship we've been looking at. But is it strong? Is it weak? Is it positive? Negative? Let's find out.
So here's the deal with Spearman's rho. The answer will always be a number between -1 and +1. Always. If you get a +1, that means you have a perfect positive relationship. As one rank increases, the other one increases right along with it. A -1 is the opposite, a perfect negative relationship, whereas one rank goes up, the other goes down. And a 0, well, that just means there's no relationship at all. Okay, so let's break down our number, 0.818. First up, the sign. It's positive, right? That tells us we have a positive relationship. In other words, as a student's rank in the exam goes up, their rank in the test tends to go up too. Now, for the strength, how strong is it? Well, 0.818 is really, really close to +1. This tells us the connection isn't just some weak little trend, it's actually a very strong positive relationship. And that's pretty much the whole shebang. From setting up that table all the way to figuring out what the answer means, you now know how to calculate Spearman's rho. It's a seriously powerful tool for finding connections in any kind of ranked data. So I'll just leave you with this question to chew on. Now that you've got this in your toolkit, what kinds of relationships in your own world, in your own field, could you start exploring?